Yes, good morning students. Today we will discuss about the MCQs based upon competitive exam point of view of the same chapter, that is the solution chapter. Solution chapter, competitive exam point of view, MCQs. That is the question number 1. Question number 1. These I will go by one, that is the simple level questions to the medium level questions and medium level question to the tough level questions. That is a level 1, level 2 and level 3, that based upon the curriculum, that is the first concentration factor type of the problems, and next vapor pressure problems, colligative properties problems and so on. Now first question, 8 gram of sodium hydroxide is dissolved in 1 liter of the solution, then its molarity is equal to dash. Now the question based upon the molarity, you know about the definition of the molarity. Molarity of the solution is given by number of moles of the solute, number of moles of the solute, number of moles of the solute divided by volume of the solution in liter, volume of the solution in liter, volume of the solution in liter. First, in the beginning I will solve the questions by means of your traditional method. Afterwards I will give the shortcut methods that helps to solve the problems within 5 to 10 seconds. Now, number of moles of the solute. You should have the awareness about how to calculate the number of moles of the solute. That is given by means of the formula weight divided by molecular weight. Weight divided by molecular weight whole divided by volume of the solution in terms of liter. If it is in ml, you convert in terms of liter. Now it is 1 ml is 1 liter is mentioned in the problem, no doubt. Therefore you have to put 1 liter. If it is a 500 ml, then 0.5 liter. If it is a 250 ml, then 0.25 liter. If it is a 750 ml, then it is 0.75 liter. If it is a 100 ml, 0.1 liter. Like that you convert in denominator. Now 8 gram of the sodium hydroxide with molecular mass 40. Now how do you calculate the molecular mass of sodium hydroxide? Sodium hydroxide formula NaOH, whereas the atomic mass of sodium is 23, atomic mass of oxygen is 16 and atomic mass of hydrogen, that is equal to 1. The total mass is found to be 40. That is called molecular mass of sodium hydroxide. Molecular mass of sodium hydroxide. Molecular mass of NaOH, that is 40. Molecular mass of sodium hydroxide is 40. That we put this 40 here. 8 gram is given, that is in data. Therefore that is 8 by 40. 8 by 40, that is equal to 1 divided by 5, that is equal to 0.2. Therefore your answer is 0.2. That is option number 3. Therefore that is answer 3, that is 0.2 molar solution. 0.3 molar solution. Okay, this is first question. This is first question. Now the question number 2. Question number 2. If 18 gram of glucose is present in 1000 gram of solvent, the solution is said to be dash. 18 gram of glucose, 18 gram of glucose that is present in 1000 gram of the solvent, 1000 gram of the solvent. Now this solvent is given in terms of gram and solute is also in terms of gram. Now it is 1000 gram in the definition of various concentration terms: normality, molarity, molality, formality. Only the denominator factor in terms of quantity of the solvent is in molality, and I will give the clue, it is a molar solution. Molar solution. Now how do you calculate the molality of the solution? That is a small atrium, that is called molar solution, that is given by means of W divided by M and quantity of the solvent in kg. Quantity of solvent in kg. Quantity of solvent in kg. If it is not in kg, you have to convert in terms of kg. In some cases, they will give in terms of the volume of the water, and they will mention at 25 degrees Celsius temperature. At 25 degrees Celsius temperature, the density is 1 gram per cubic centimeter, and hence 1000 ml of water is equal to 1000 gram of the water. That is hint. Whereas 18 gram of glucose present, whereas glucose molecular mass, glucose molecular mass, glucose formula is C6H12O6. Glucose formula is C6H12O6. Here 6 atoms of the carbon are present, and 12 atoms of hydrogen are present, and 6 atoms of oxygen are present. There is a carbon atomic mass is 12, hydrogen atomic mass 1, and oxygen atomic mass 16, and hence the total value is found to be 72 plus 12 plus 96, that is equal to 180. Therefore, the molecular mass of glucose is equal to 180 whole divided by, where the quantity of the solvent is in terms of 1000 gram, that is 1 kg. Therefore, 18 divided by 180 divided by 1. Therefore, that is equal to 18 divided by 180. 18 divided by 180 is equal to 0.1. This 0.1, that is in terms of molar solution. 0.1, that is a molar solution. Therefore, the question number 2, that is option number 4. Answer 4, that is 0.1 molar solution. 0.1 molar solution. Okay. Next question. There is a question number 3. The molarity of a solution of sodium chloride, within bracket the molecular weight is 58.5, in water containing 5.85 gram of sodium chloride in 500 ml of the solution is dash. Now again, this is a problem that based upon, that is the molarity of the solution. Now this is third problem. Third problem, it again based upon molarity problem, that is a revision once again with a different compound. The molarity of the solution, that is a problem that based upon sodium chloride, that is M. Again, this is weight divided by molecular mass and volume of the solution in liter. 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 Or you can have this W divided by M whole divided by V by 1000. If it is 1000 ml is given, fine, no problem. If it is not in 1000 ml, better to use this formula, that is the given volume divided by 1000. Now it is a sodium chloride. Molecular mass is given. For sodium, atomic mass is 23. For chlorine, atomic mass is 35.5. Therefore, the molecular mass is equal to 58.5. Now the given amount is 5.85. The given amount is 5.85. With molecular mass you have to calculate or may be given in the problem, that is a 58.5 whole divided by 500 ml of the solution. 500 ml of the solution whole divided by 1000. Why they are using 1000? In order to convert the given volume in terms of liter. If the given volume is 1000, no problem, the denominator always 1. If the given volume is not 1000 ml, then divide by 1000 ml. This 5.85 divided by this is 0.1, 0.1. Now this is 500 divided by, that is equal to 0.5, 0.5, 0.5. Now this is equal to 1 by 5, 1 by 5, that is equal to 0.2, 0.2. Therefore, the third problem, the molarity of solution of sodium chloride, which contains 5.85 gram of the sodium chloride in 500 ml of the solution, can be labeled as a 0.2 molar solution. Therefore, for answer 4, that is 0.2 molar solution, 0.2 molar solution. Okay. Next, question number 4. Question number 4. For preparing 0.1 molar solution of sulfuric acid in 1 liter, we need sulfuric acid is equal to dash. Whereas molarity required is 0.1. Molarity that is given as a 0.1. 0.1. How much quantity of this weight of the salt is, that is a substance is required, not mentioned. There is a molecular mass of sulfuric acid. Molecular mass of sulfuric acid, that you have to calculate. Molecular mass of sulfuric acid you have to calculate. But you should know the data, that is atomic mass of hydrogen, that is equal to 1. Atomic mass of sulfur, that is 32, whereas atomic mass of oxygen, that is 16. Therefore, molecular mass of sulfuric acid is given by 2 into atomic mass of hydrogen plus 1 into atomic mass of sulfur plus 4 into atomic mass of oxygen. That is given by 2 into 1 plus 1 into 32 plus 4 into 16, that is equal to 2 plus 32 plus 64, that is 98. Therefore, the molecular mass of sulfuric acid is equal to 98. Therefore, M is equal to 98. M is equal to 98. Volume of the solution is given, that is 1 liter. 1 liter. Therefore, you know that 0.1 is equal to W divided by molecular mass, that is 98, whole divided by 1 liter. Whole divided by 1 liter of the solution. They mentioned in 1 liter. Therefore, you have to calculate W. Therefore, W divided by 98 is equal to 0.1 into 1, that is 0.1. Therefore, W is equal to 98 into 0.1, that is equal to 9.8. Therefore, the quantity of the sulfuric acid that is required to prepare 0.1 molar solution is 9.8 gram. 9.8 gram. Therefore, answer is fourth answer. Answer 4, that is 9.8 gram. 9.8 gram. Now this is question number 5. Question number 5. Mole fraction of glycerine in a solution of 36 gram of water and 46 gram of glycerine. Whereas the glycerine having the formula C3H5OH thrice. C3H5OH thrice. In a solution of 36 gram of water, in a solution of 36 gram of water, and 46 gram of glycerine, and 46 gram of glycerine. 46 gram of glycerine. Here this is based upon the mole fraction problem. Mole fraction is given by the number of moles of the individual component divided by the sum of the number of moles of the mixture. Sum of the number of moles of the mixture. Here you have to calculate the molecular mass of glycerine. Molecular mass of glycerine. Formula is given C3H5OH thrice. CH3H5OH thrice. That is 3 into atomic mass of carbon plus this is 3 plus 5. This is 8 into atomic mass of hydrogen plus 3 times of oxygen. 3 times of oxygen. You have to calculate. That is 3 into atomic mass of carbon is 12 plus 8 into atomic mass of hydrogen is 1 plus 3 into atomic mass of oxygen, that is equal to 16. You know that the carbon atomic mass 12, hydrogen atomic mass 1 and oxygen atomic mass 16. That is 36 plus 8 plus 48. That is equal to how much? I think that is 92. Therefore, 92 gram of the glycerine corresponds to 1 mole. Now, this is molecular mass of water is 18. Molecular mass of water, that is equal to 18. Already you know, because formula is H2O. Now 46 gram of glycerine corresponds to how many moles? That is weight divided by molecular mass. That is equal to 46 divided by 92, that is 0.5 mole. And 36 gram of water, that is corresponds to 36 divided by 18, that is equal to 2 moles. Now suppose N1 is equal to 0.5 mole and N2 is equal to 2 mole. Therefore the mole fraction of glycerine, that is given by N1 divided by N1 plus N2. N1 is equal to 0.5. N1 is 0.5 plus 2.0. That is 0.5 divided by 2.5. That is equal to 1 divided by 5. Again that is 0.2. Therefore the mole fraction of glycerine, that is equal to 0.2. Therefore answer for the question number 5 Answer for the question number 5, that is 3, that is 0.2. It is a mere number, has no unit. Now the question number 6. Question number 6. Number 6. There is 1000 gram aqueous solution of calcium carbonate. Aqueous solution of calcium carbonate. Aqueous solution of calcium carbonate contains 10 gram of calcium carbonate. Contains 10 gram of calcium carbonate. 10 gram of calcium carbonate. The concentration of the solution is dash. The concentration of solution. We can express the concentration in various methods. Where is the option that contains only parts per million? Therefore, you have to convert in terms of the parts per million. You know that parts per million, that is aqueous solution. This is in terms of mass of the solute divided by mass of the solvent. Mass of the solute, because both are in gram. Mass of the solute in gram divided by mass of the solution. That is also in terms of gram into 10 to the power of 6. We can express the ppm in various methods. Mass of the solute divided by mass of the solution into 10 to the power of 6, or volume of the solute divided by volume of the solution, both are in liters or ml, into 10 to the power of 6, and mass of the solute divided by volume of the solution into 10 to the power of 6. We have different methods. Where the mass of the solute is given, that is calcium carbonate, that is 10 gram, and mass of the solution, that is 1000 gram into 10 to the power of 6. Now this is 10 to the power of 6 into 1, 10 to the power of 7, 10 to the power of 7 divided by 10 to the power of 3. Answer is 10 to the power of 4, that is 10,000 parts per million. 10,000 parts per million. Therefore, your option is 4. Answer is 4. Answer 4, that is 10,000. Answer 4, that is 10,000. Now, next one is question number 7. Question number 7. What is the normality of 1 molar phosphoric acid? Normality of 1 molar phosphoric acid, H3PO4. Normality of 1 molar orthophosphoric acid. Structure of orthophosphoric acid, that is structure. This is orthophosphoric acid. Therefore, here the basicity of an acid, that is number of OH minus ions that it contains. Therefore, here N factor is equal to 3. Here normality and molarity. Normality is given by N into M, where N is equal to normality, M is molarity, N is equal to valency factor. In this example, valency factor is equal to 3. Therefore, normality is equal to molarity is given, that is 1 molar into 3, that is equal to 3 normal solutions. N is equal to 3. N is equal to 3. Therefore, that is option 4, answer 4. Answer 4, that is a 3 normal solution. 3 normal solution. Okay? You should know about the structure, or you should know about the n factor. N factor. Next, 8. The molarity of 0.2 normal sodium carbonate solution is dash. Molarity of 0.2 normal sodium carbonate. 0.2 normal sodium carbonate solution. 0.2 normal sodium carbonate solution. Now, for sodium carbonate, we have Na plus 2 times or CO3 2 minus. Therefore, the number of charged particles plus 2, here minus 2. Therefore, n factor is equal to 2. N factor is equal to 2. The molarity of 0.2 molar solution. Molarity, you know that n is equal to nm, small nm, where n is equal to normality. Normality is given, that is 0.2. N is given, that is 2. Therefore, molarity of solution is given by n divided by small letter n. N divided by small letter n. N is given, that is 0.2. Small n is given, that is 2. That is 0.1. Molarity of solution is 0.1. Therefore, option is 3. Answer 3, that is 0.1 molar solution. 0.1 molar solution. Now, question number 9. Normality of 0.3 molar phosphoric acid. Normality of 0.3. Normality of 0.3 molar phosphoric acid. Orthophosphoric acid. Now you know the structure of the orthophosphoric acid. If it is HOH, OH, OH. Here n factor is equal to 3, 1, 2, 3. Normality, molarity is given and I have to calculate the normality. Therefore, n is equal to n into m, whereas n is small n is given as a 3, molarity is 0.3, that is equal to 0.9. Therefore, normality of the solution is 0.9. Normality of the solution, 0.3 phosphorus acid, not phosphoric acid, phosphorus acid. H3PO4. If it is orthophosphoric acid, this is fine. Okay. If phosphorus acid. If phosphorus acid problem is there, phosphorus acid. Now this molarity of the solution is given by the ratio of the amount of the substance to the molecular mass to the volume of the solution in terms of liter. Since that is 1000 gram of corresponds to 1 liter of the solution. Therefore, that is 1000 by 18. 1000 by 18, that is equal to 55.5. That is 55.5. Therefore, the molarity of the pure water is that is a 10th problem. Molarity of the pure water is equal to 55.5. Molarity of the pure water is 55.5. Now, molarity of 720 gram of water. Molarity of 720 gram of pure water. Molarity of 720 gram of pure water. In the same method you have to solve. That is given by means of the formula. Whereas the molarity is always fixed. Number of moles of water in 720 gram, that is equal to 720 divided by 18, that is equal to 40. And volume of this water, in a liter. Since 720 gram is equal to 720 gram, that is equal to 720 ml of the solution. That is, volume is given by 720 divided by 1000, that is equal to 0.72 liter. Now substitute in this formula, that is m is equal to, that is a 40 divided by 0.72. 40 divided by 0.72, that ratio seems to be 55.55. That is found to be 55.5. Therefore, the molarity of water is always fixed for the pure water. Next one is equal weight of sodium chloride and potassium chloride are dissolved separately in equal volume of solutions. Molarity of the two solutions will be dash. Molarity of the two solutions will be dash. Now consider this is a molarity of the sodium chloride and consider this is molarity of the potassium chloride. Now weight of the sodium chloride divided by molecular mass of the sodium chloride divided by volume in liter. Volume of the solution in liter. Here weight of the potassium chloride divided by mass of the potassium chloride divided by volume of volume in terms of liter, volume in terms of liter. In the problem they clearly mentioned the mass of the sodium chloride and mass of the potassium chloride are equal and volume of this solution both are equal. Therefore, this and this will get cancelled and this will get cancelled. Here it is molarity is inversely proportional to now it is inversely proportional to molecular mass. Molarity is inversely proportional to molecular mass. Molarity is inversely proportional to molecular mass. This is true if and only if whenever the volume of the solution that is fixed and quantity of the solutes are fixed. Now, molecular mass of sodium chloride, molecular mass of sodium chloride and molecular mass of potassium chloride when consider. Molecular mass of potassium chloride consider. Molecular mass of KCl molecular mass is greater than NaCl molecular mass. KCl molecular mass is greater than NaCl molecular mass and hence molarity of NaCl is greater than molarity of KCl. Molarity of NaCl is greater than molarity of KCl. Okay, this is question number 12 is over. Question number 12 is over. Therefore, that is option 3, answer 3. That is the molarity of NaCl is greater than molarity of KCl.